this working? Okay. Hi, everyone. Thanks so much for coming. It's a great crowd. I'm Reed Albergotti. I'm the technology editor for Semafor. Super excited for this panel. I'm just going to introduce our amazing panelists here. Max Tegmark is an MIT professor. He's also the president of the Future of Life Institute. And in March of last year, he wrote a letter calling for a 6-month pause in the development of these advanced AI models, and it was signed by, I think, over 3,000 people, including Elon Musk and Apple co-founder Steve Wozniak. So
30,000.
30,000, yeah, sorry. I knew it had a 3 in it. David Haber is CEO of the AI safety company Lakera, or security company Lakera. He's also the creator of a fascinating game called Gandalf, which you all should play. You try to trick...
Not right now, please.
Not right now. You try to trick a large language model into divulging this password that it's been told not to divulge, and it gets harder at every level. It's sort of like a prompt engineering IQ test. Have you guys all how far have you gotten in that, by the way?
Level 4.
Seraphina Goldfarb-Tarrant is the head of safety for Cohere, which is a developer of some of the biggest, most important foundation models. And she sits at this intersection of where you take these models and really implement them at companies that are big and small. So she has sort of this on-the-ground, real-world knowledge, as well as a great background in safety. And last but not least, we have Yann LeCun, who is the chief scientist for AI at Meta. He is one of the pioneers of deep learning, so ahead of his time that for years, people basically mocked his work until it basically took over the world and led to spawn these technologies like ChatGPT. And I think we can just get right into it. So the panelists have a bunch of different views. I don't think they agree on everything, which should make for some good some good conversation. So we're going to talk about what's happening now in the world of AI, and then we'll sort of move on to what the risks are, what we should be thinking about into the future, and what we might do about it. So let's start with you, Seraphina. So you're, as I said, working with companies. Cohere is working with companies to implement these models every day. So what's like the biggest issue that they are finding as they start to use this technology?
Yeah, so I think the biggest issue that we see since we do predominantly enterprise deployments, like I worry a lot about misuse, but that's mostly from like API stuff. From enterprise deployments, the biggest issue we're actually running into is like a combination of two things that are very bad together, which is no good method of evaluation and extreme scale. So meaning that like any small, like fundamentally we're trying to do risk mitigation. So we're trying to find rare events that are really problematic. And even if you have really big scale, which many of our customers do, right? We have like huge, like Oracle has like, when something is deployed, it's deployed very broadly. And so if there are like small issues with like generalization where it won't generalize to certain types of things or types of social biases that are into the model, that even if they're very, very low frequency, it can be propagated very, very broadly anyway. And we don't actually have, like, generative AI pretty much broke our methods of evaluation. We don't have, like, nobody has good methods of evaluation right now.
So David, why do companies need something like Lakera Guard? What are the biggest challenges that they're facing now? And what are you helping them solve?
Yeah, I think we should take a step back and think about what has really changed over the last 1 to 2 years. And I think part of that goes into what Seraphina just said, is we see all these companies deploying things at massive scale. And so again, we work with companies, they've got a couple of teams, they're deploying to hundreds of millions of users out there. And so all the things that we worry about, they propagate to these users. Part of the reason is that we've got a bit more of a unified and universal interface that now everyone can interact with. We've talked about Gandalf. The reason why it's been so successful is because I just had a conversation, 12-year-olds can go and play with that game. The technology is so much more accessible. And at the same time, we bring completely new capabilities that we don't know about ourselves, that model builders don't know about, to these hundreds of millions of users. And I think we are just getting into the next stage as well, and we are actively working with companies on that, on preparing them for what we would refer to as the Internet of Ages, or Internet of Agents, where you have all these agents that ultimately take over a lot of the work that we may have previously been doing, and again, execute them at scale. So you've got the interface, you've got the capabilities, and you've got the interconnectedness of systems that ultimately amplify, in line with what Seraphina said, a lot of the risks that we are seeing here.
Yeah. So the World Economic Forum just put out their risk report, and they said that AI-fueled misinformation, disinformation is the biggest issue for the economy in the near term, the next few years. So Max, do you agree with that?
No. I agree that it's the most important issue for this year. This is going to be the year of fake. You know, more than 4 billion people are going to the elections.
Yeah.
Just brace for yourself for some really hardcore deepfakes. Deepfakes, whether it be images or voice or videos used for fraud, 90% of them are used for non-consensual pornography, often on underage girls. All sorts of awful things. Yeah. So this year, yeah, but 3 years, absolutely not. I mean, we have the leaders of Google DeepMind and OpenAI and Anthropic talking about getting artificial general intelligence in 3 years or 2 years. So it's certainly not only fake news and misinformation we have to focus on. And I think taking a little step back, this is an incredibly exciting point in time, as you both mentioned, right? Because ever since 1951, Alan Turing said that, you know, human-level AI is really, really far off. But he didn't just say that. He also gave us a test for when we should start paying attention. You know, when machines pass the Turing test, when they get so good at language and knowledge that they can start fooling a lot of humans. And there is still some disagreement about whether we've passed the Turing test or not. But, you know, Yann's fellow Turing Award winner, Joshua Bengio, argues that we already have passed it now. There was a nice paper out a month ago where they actually tested it. And 62% of the humans passed the Turing test and were able to persuade other humans that they were not computers, and 42% were persuaded that GPT-4. So after, you know, we've waited since 1951, and it's kind of now that it's happening, and that's why things are happening like you described. And so I think, yes, we absolutely have to deal with this information, but we also have to look at what comes after that.
Yann, you know, you've been thinking about these risks for a long time, right? You founded the Partnership for AI in 2016, which is, you know, I think one of the early kind of AI safety organizations. I'd love to know, actually, do you think that the Turing test has been passed? And if not, like, what are the biggest risks for like today's AI?
Yes, the Turing test has been passed, but what that means is that the Turing test is a terrible test. Because we're nowhere near human-level intelligence, okay? It's not because we have systems that can beat us at chess, like a $30 gadget can beat you at chess. You can beat me at chess, certainly. Or computers that can beat us at Go, or beat us at diplomacy or poker, or pass the bar exam. I hope there's not too many lawyers here. That it's not because you pass the bar exam that you're smart. Okay, you can do this by retrieval, and that's basically what LLMs are doing. They're doing intelligent retrieval and interpolation. They're nowhere near human-level intelligence. We're still missing some very, very basic things. Why is it that, you know, a cat can plan a complex trajectory to jump on a piece of furniture? We can't do this with robots. Why is it that a 10-year-old can learn in one shot to clear up the dinner table, fill up the dishwasher? We're nowhere near being able to do this with robots. And it's not because we can't build the robots, it's because we can't make them smart enough. And we still don't have level 5 self-driving cars, and a 17-year-old can learn to drive in 20 hours of practice. Okay, and we have hundreds of thousands of hours of training data, and we still can't get it. So obviously, we're missing something really, really big. And so we're nowhere near human-level intelligence, despite what you might hear from the most optimistic people who tell you AGI is just around the corner, and we need to regulate now because it's very dangerous. I have 3 predictions. First, there is no such thing as AGI because human intelligence is specialized. So we can talk about human-level intelligence, but the components that we're missing would lead us to something like cat-level intelligence before that. Okay. I'd be happy if by the end of my career we can get something as smart as a cat. It's coming fast, by the way, the end of my career. So that's the first point. And the second point is, to get to that level will require some scientific breakthroughs. This is not a technological issue. So if we want to, right now the performance of LLMs is saturating. They're trained with 10 trillion tokens. This is basically all the data, all the public data we can get off the internet in the form of text. If you quantify how many bytes that represents, it's about 10 to the 13 bytes. 2 times 10 to the 13 bytes, okay? Because it's 2 bytes per token, 10 trillion tokens. Now, think about how much data gets into the visual cortex of a 4-year-old by the time the kid is 4 years old. 16,000 hours of being awake, times 3,600 seconds per hour, times about 20 megabytes going to the visual cortex through the optical nerve. That's 10 to the 15 bytes. That's 50 times more than all the data that is used to train LLM. And if you were to read all the data that we use to train LLM, it would take you 170,000 years. It would take me 200,000. So we're doing something wrong. I mean, everybody is talking about using more data, more compute, blah, blah, blah. We get really smart really fast with a lot of data, but it's much more, high bandwidth data. And we're not that smart. Like, octopus get really smart in 6 months, and we don't know how to do it.
And I know you have this world model, which maybe we can come back to, but there's a, I'm trying to square what you said with research papers like Anthropic recently put out, I think a couple days ago, right, where they said they trained an LLM to be deceptive. And then once they did that, it was impossible to, or almost impossible to get it to go back, right? It just kept tricking the user. So there are these kind of frightening headlines. So what do you, I don't know if all of you saw that paper or read it, but how do you square that, Yann? And I'd love to hear your other panelists' thoughts too.
Well, Anthropic seems to be partly in the business of scaring people with AI. So, and then telling them, like, come to us because, our AI systems are not scary. But, it's another example of, oh my God, a system can beat you at chess. Yeah, it can beat you at chess. Yeah, it can recognize species of insects better than you can. It can translate, 200 languages in any direction, which no human can do. So, we're familiar with this idea that computers can do better than humans in a number of different fields, and this is going to continue. It's going to get expanded. But what that proves is that, again, we don't have general intelligence. We suck at a lot of things. We suck at chess. We suck at Go, certainly. So let's forget about this idea of general intelligence, right? So what is intelligence? It's a collection of skills and an ability to acquire new skills very quickly. And that's, collection of skills. Classical AI was trying to deal with this. Acquiring new skills quickly is what machine learning has been trying to do. But so far, we're missing the quickly.
Max, do you kind of dismiss that research too, or when you read papers like that, are you concerned?
Well, I think people who only know my conversations with Yann from Twitter probably don't realize how much Yann and I actually agree on. So, for example, I completely agree with everything Yann was saying here about how lame today's state of the art is, compared to what brains do. Just sort of flogging a dead horse here, I think. But if you just count how many how many megawatts are going into these large data centers, and compare that with the fact that Yann can do it with 20 watts with his brain. It just shows you that what we're actually doing in the field now is compensating for our incredibly poor algorithms with just huge amounts of overkill on hardware and data. So what I would expect to happen in the future is that once we make a lot more progress, we'll be able to run things that are much better than GPT-4 with vastly, vastly less hardware and data and so on. And I also very much agree with you, Yann, that today's architectures are, we need new architectures. You know, I think transformers, which are all the rage today, that's the nerd term for the basic neural network architecture powering ChatGPT-4, for example. We're going to be remembering them as the vacuum tubes of 2023. The first technology that really got us was close to doing cool things, but something we'll laugh at later when we have much better ones. On the other hand, in terms of predictions, I think it is very clear, and here I think Yann and I also agree that there's been a big shift. You know, 3 years ago, if you look at, for example, the prediction site Metaculus, which is probably the most trustworthy one out there, the timeline left until actual AGI, you know, was 40 years, and it's dropped on the prediction site from 40 years away to 2-3 years away in just 18 months. And even you, Yann, I'm curious if you can confirm this or if this was just bad journalism, but I saw you quoted saying that, oh, it won't happen for a long time, not until at least 2028.
But let me just before you answer that, I mean, this Metaculus site, I mean, I've been to, it's like where you can gamble. You basically bet on when AGI will come. But these are not bets based on, I mean, you don't know who these people are.
It's the trust in people there is earned because they have made correct predictions in the past. It's exactly the opposite from political pundits where they just keep predicting things, no accountability. In science,
but I went on and I you know, I bet.
Mm-hmm.
So,
but if you've made a lot of successful predictions before, will your predictions really get upscaled? It's just like you trust scientists not because they're rich or whatever, but because they made correct predictions in the past, right?
Okay. Do you all trust it? What do you think, Seraphina?
Scientists do not make correct predictions in the past. Like, in fact, one of my favorite, websites is Rodney Brooks, because he specifically goes through how all of his predictions were wrong and gives you like the paper trail, and that is what I respect in a scientist. But like, I think that's an example of a very good scientist. You're often very wrong. And like, I think like a lot of this conversation has reminded me, and you were, Yann, talking about self-driving cars, right? So like, I remember I was like starting to get into ML when self-driving cars were like the rage, and everyone like Sebastian Thrun was up there, who does incredible work, and was like, oh, they'll be here in 5 years. But that was like over 15 years ago. And like, some people do now say, oh, they're here, but it's because they have redefined them into existence. Like, you're being like a 17-year-old is much better because like the original notion that people were thinking of has become simplified. And so we have achieved those goals because they've been like, well, self-driving is possible as long as you're on a road that's like this, and like only as there's not too much traffic, like long distance, like sort of like this sort of thing. And I'm starting to see this with AGI, in that like I'm starting to see lots of people who've been making really big claims about AGI like dial them back and be like, well, like even OpenAI recently, and they're like really big on the AGI game, obviously, it was saying like, proposed like, oh, let's redefine it as exceeding human performance at like sufficiently like commercial goals or something along those lines, which lots of baggage to talk about there, but I'm seeing that in lots of other people as well, where it's like maybe less of a grab for space than OpenAI's, but like lots of people just dialing back, and I don't know, and then you're just not really having the same conversation actually, because some people are imagining something that's hopefully better than their cat, and some people are imagining something that's like better at writing a grant application than they are.
So do we need something new, like a new Turing test? I mean, I think Mustafa Suleyman, who I think predicted that it's going to happen very, very soon, but had this different Turing test where can an LLM basically run a business and do a whole bunch of other things? Do we need something like that to like a solid benchmark?
There's not going to be a single test because, again, it's a collection of skills. Which skills are you interested in? And so, depending on which system you build for what skills, you're going to have certain skills and not others. And so you cannot have a single test. Intelligence is not a linear, scalar quantity. It's, again, a set of skills. Like the type of intelligence, chimps are smarter than us at certain things. We are smarter than them at other things. And, cats and badgers have different characteristics. They're built differently, and they are primed by evolution to learn certain things and not others. So we're not going to measure this with a single scale. It's just not going to happen. And therefore, there's not going to be a single test. It's going to be a collection. But the history of AI is a history of, okay, this test is the good one. Now, if AI systems can do this, now they're intelligent. A few years ago, that was the Winograd schema. Do AI systems have common sense? And it's been beaten. And it's not because AI systems have common sense. It's because, it turned out it was easier than we thought. Or playing Go, obviously that's, super conceptual and everything. You can't do it with tree search. It's true, you can do it with tree search, but you can do it with a small ConvNet. So, we keep coming up with those tests and we keep beating them. And there is no single test that really measures intelligence.
Yeah.
I feel there's just way too much pessimism right now on this panel.
No, I'm very optimistic.
To have
on the contrary,
exciting impact in the world with AI, we don't need AI to be able to be exactly like a human. And we also don't need to be as efficient as a human and be the size of a human. We can put in a lot more volume, a lot more power if we need. And I think what's obviously happening is that Yann is right. We need new architectures, but I just came back from the NeurIPS conference, 14,000 people. So much talent has gone into the field. So many people are working on combining these current architectures with all sorts of other ideas, often from more sort of old-fashioned AI planning, et cetera, and for people who want to be pessimistic, I challenge you all to make a list of concrete things that you're convinced AI will not be able to do 2 years from now, and actually write them down. And I think you'll find that it's a little scarier than you think to stick your neck out and say AI will not be able to do this in 2 years. AI will not be able to do that. Rodney Brooks, who you lauded, he told me not so long ago that he was sure that there would not be anything close to human level intelligence for 300 years, 100%, And so I don't know anybody other than Rodney Brooks now in the whole field who would say something so extreme. So if there is something, if you want to be pessimistic, tell me what AI won't be able to do, concretely.
Okay, you're right that we don't need to match human intelligence for AI systems to be useful. They're already useful, and they're nowhere near human level. So there's a whole industry, which is very good, based on, vision systems, LLMs, translation, all that stuff, right? It's great. But there is actually a good reason to get machines to human-level intelligence. And it's because there is a future where every single one of our interactions with the digital world will be through an AI system. So AI systems will be our assistant, day-to-day, minute by minute. They'll live in our smart glasses or smartphone or perhaps in the cloud, but we'll be talking to them all the time. They'll help us in the daily lives, like initially like a not very smart human assistant, eventually like a very smart human assistant, eventually like a really smart staff working for us. Okay, but there will not be a staff of humans. They'll be under our control, so I don't believe in the takeover or whatever. They might be smarter than us in many areas, in all domains. We shouldn't feel threatened by that any more than we feel threatened by working with people who are smarter than us. At least I don't. I try to hire people who are smarter than me. So we need this because it's gonna happen. It's going to basically amplify, the collective intelligence of humanity and cause a new renaissance. How is that for optimism? All right. Now, how long is that going to take? I have no idea. And there is a very, very long history going back to the 50s of people being overly optimistic about what the new method that they just invented was capable of doing. And we're seeing exactly the same thing today with LLMs. The people who think that you just scale up LLMs and eventually they'll get to human-level AI, that's just false. But we're going to get there, okay? 5, 10, 20 years, I don't know. It depends on some breakthrough that we haven't achieved yet. And I don't know how long it's going to take. But it's harder than we think.
But I think to add a bit more optimism even to this, I think the one thing I disagree on is it's already happening. I think we just ChatGPT Teams launched the other week. I walk around the office now. We've got engineers coding with Copilot. We've got our marketing team being supercharged by AI. So I think, first of all, what I wanted to say earlier, I think the one thing we've learned is the human has been a terrible comparison point for anything we do, a really terrible one. And I say that in many ways. I think we can aim a lot higher in many ways. We should aim to make people or hire people that are smarter than us. The human is a terrible comparison point. And so my big question is, where do we even apply these tests? And I think if I walk around the office seeing all these amazing things happening with AI right now, I think that's where I see the tests happening at the application level. One AI really good at coding, the other one really good at generating great content for us, and so on. So I think it's already happening right now. I don't think we have to wait too long. We see this happening today.
It's useful today, but we're nowhere near human-level intelligence. That was my point.
I think there's something interesting about capabilities here, which is that I think, at least when I hear people who disagree about stuff often, I think fundamentally, our AI systems are picking up patterns in vast amounts of data, right? And so it's hard to reason about because we're not used to reasoning about what patterns can you pick up in 5 billion hours of speech? As humans, we're not super good. But so I think often people agree on this, but what we disagree on is what sorts of things you can learn that way. Based on the architectures we have now and clever stuff like that. And so I think I thought of this because of your coding example, actually, because it's always been really interesting to me. One of the really early things when AI systems came out is they're programmers are going to be replaced and stuff. And it's sort of but what we've actually seen is that I can't use a coding assistant because I'm a scientist. And usually if I'm sampling from some distribution, that's not a really easy pattern to learn from lots of data. So it's not something that language models are good at now. Whereas a lot of sort of dev work that's from an API or something like that is a very easy pattern. And so I think there's an interesting distinction as far as capabilities that we see there of which ones are easy to learn from big data and which ones are not.
So I want to just change gears a little bit. I want to talk about open source because there's this interesting thing happening with open source. Meta has put out Llama 2 and other models that are open source. They're leaning hard into that philosophy. Cohere, I think, does both closed and open. And Fortune just wrote an article. I'm sure you saw this, where there were some bad actors creating chat bots that were these sex bots basically, and some of them were pretending to be underage. It's all text-based stuff, but obviously not good. And then there's also this debate about the long-term risks of open source. But I'd like to ask Yann first, what do we do about it today? How do we keep it, keep those models from being abused?
Okay, there's a number of different points in the chain, right? There is research and development, open source platforms, and then there is products which may be free or not free, proprietary or not, that you build on top of those platforms. When you put a product on the market, there may be some regulation in the market that you're deploying your product in, and it has to be deployed in a way that, of course, makes sense and is beneficial, right? Otherwise, people will sue you, or the government will, complain. Regulators will come to you. But that's at the product level. That makes complete sense. Regulation at the product level. Regulation of R&D makes no sense. It's very counterproductive, and it's throwing the baby with the bathwater. Even worse, the solution to preventing bad people from doing bad things is not to stop progress on good things, right? Because they will get it anyway, right? So, and the reason why we need to accelerate progress, and the best way to do this is through open source, is that is that the best countermeasures against bad uses of AI is better AI. So people may or may not know this, but fake news, hate speech, child pornography, all kinds of those bad things. They've been around for years, and people are trying to use social networks, including Facebook and Instagram, to distribute those contents. There's a big organization within Meta called Integrity, whose only job is to basically take that down, design systems to take that down, and it uses the latest AI technology. The proportion of hate speech, for example, that is taken down automatically by AI systems before anybody sees it was 23% in late 2017. Last year it was 95%, and it's entirely due to self-supervised training applied to transformers, basically, right? So, and that works in every language in the world. We couldn't do this before. Same for dangerous disinformation, etc. We don't have any magic solution, of course, to disinformation, but the problem with disinformation is not at the creation level, it's more at the distribution level. So social networks have a big role to play there. But there is a more important question about open source, which is that, again, in this picture, where every single one of our interaction with the digital world is mediated by an AI system, our entire digital diet is going to be determined by those AI systems. We cannot have those systems be controlled by a handful of companies on the west coast of the US. Governments around the world would not accept this. They will not accept that all the political information that their citizens are getting, first of all, mostly works in English, and second of all, has the values of whatever is trendy in Silicon Valley at that time, or whatever is trendy in the training data that is being used to train and fine-tune those systems. We need AI systems that work in every language and dialect in the world. And we're not going to do this unless we have open source platforms where the fine-tuning can be crowdsourced. There was a really nice example just a few days ago of a group in India that fine-tuned Llama 2 to handle the Kannada language, which is spoken in southern India. I mean, that's great. That's the best thing. That's the reason why we have open source platforms. We're not going to have a single AI system. We're going to have a whole bunch of AI systems that cater to various cultures, languages, values, center of interest, etc., by basically crowdsource people. It's going to be like Wikipedia that you can talk to, essentially.
Anyone else have strong thoughts on open source versus?
Yeah, I love open source. MIT is, in some sense, arguably the cradle of open source, right? And I have open sourced every piece of research I've ever done with my group on AI and other things. I think, though, and I share Yann's concern about excessive power concentration. I think open source is really important to counteract that. At the same time, I think we want to move beyond slogans and look at things more nuanced. So if we just say that the best way to stop a bad guy with AI is with AGI is a good guy with AGI, it sounds a lot like the National Rifle Association slogan, right? And the fact of the matter is, if you look across other areas of technology.
So no, it sounds like the necessity for police. It's a different thing, right? We're not giving AGI to every citizen so they can kill every other AGI.
Right, but gun control means you want to make it a little harder for everybody just to buy their own gun, right? So I'm
not talking about gun control. I'm talking about police.
So my point was just if you look at other areas of technology where technology has the potential to do harm, and I think one thing I think Yann and I do disagree a little bit on is I think Yann, you often make the assumption that everybody else is as nice as you are, and in other areas we don't open source, even in America, hand grenades or machine guns or miniature nuclear weapons in physics and biology. You want to open source most of your research, but not gain of function research. If you make a super smallpox that kills 99% of everybody who gets it and is airborne, you wouldn't open source the DNA. So what we always do in other fields is, I think, what makes sense for AI also. You open source almost everything, but somewhere there's a line, and you have a calm and level-headed discussion about where to draw the line exactly between what should be open source and what shouldn't. It's not a binary debate where you open source everything or nothing.
Mm. So I think we need to start. The last thing I want to do is I'd love for everyone to just come up with if you have sort of your final thought on this subject, just what we didn't get to, or something you want to say, and I maybe start with Seraphina.
Starting with me. Okay, what is the sort of thing what do I really want to say? I think, okay, so of all the things that I want to say about risk and promise as well, I think a huge amount, there's two things, I guess, I'm going to cheat, is one, I began by talking a little bit about evaluation, because I think largely people think about it incorrectly. So in that there's sort of like, and I like what Yann said about, then we need a new test, We're used to, we test something often because we assume, that it has, like, our test has to be really either a super good simulation of like the environment that we're talking about, or it has to be like correlated with some behavior. And we're frequently finding that that's super hard. And so the whole industry is kind of reliant on like red teaming and stuff like that, that's like vulnerability discovery. That's not evaluation. Evaluation is like, is actually comprehensively doing a simulation of some situation. And nobody is doing that right now. And it's been really hard. Like when I first started this, it was in like old statistical MT, and like people haven't been able to do that. And that's a much narrower domain, right? Translation, what the original source is. So it's much easier to evaluate than just like talk to me. So there's that. And then the second one is that I think people also really, really underestimate the sort of complexity impact of the data dependency. Like there's a reason, we're talking about open source and closed source, there's a reason that the thing nobody will tell you about is their training data nowadays. Because it is part and parcel of what makes these models what they are nowadays. It's also why closed book models are currently better than open source ones in lots of ways, is the amount of time that's been spent on that. And I think when we think about risk management, we're not often thinking about it on the scale of big data, of what comes out of your data, like what patterns were in there and which ones don't you want. We think of it in terms of like code. We're used to thinking of it in terms of code, but code is much easier to analyze as far as like tech debt and worries about it. So I think those are the two that I'll leave you with.
All right, Yann.
Okay. To get machines to the next level of intelligence, we need them to be able to understand the world, the physical world, perhaps learn like baby animals or humans, to remember, to plan and reason. And today, LLMs, autoregressive LLMs, which is what they should be called, are not capable of any of this. Okay, the small capabilities that they can do within those things, like planning, is just because they regurgitate plans that they've already been exposed to in their training set. So that's the next frontier. We're not going to get anywhere close to human-level intelligence unless we do this. My prediction, and the second point, is that autoregressive LLMs are intrinsically unsafe. They cannot be fine-tuned to death to be safe. It's not possible. You can always jailbreak them. And so we need a new architecture that will enable those features I was just talking about, but also will make system controllable and safe. Okay? So my prediction is that if we get to the breakthroughs that are necessary for this, within 3 to 5 years, nobody in their right mind would be using autoregressive LLMs. And so all the discussions we have about safety that are basically extrapolations of what LLMs can do today are false. We should not think about this. It's as if we were asking people in 1925, how are you going to make jet airliners safe? The turbojet was not invented yet. So that's the situation we're in. So until we have a basic blueprint that will take us to like cat level intelligence, there's no point talking about existential risk. It's going to take a while.
Okay, Max.
The one thing I would probably say is we are probably in a bit of a faster moving industry than aerospace. So that's something we should probably take into account. I think as a matter of fact, and I know we have to wrap up soon, but it feels today that you have a dinner conversation with someone about AGI and you're not even talking about the same thing. So I think there is a certain probability in the future of all of these risks happening, some P that may vary from country to country and from person to person. But I think there is 100% chance that companies are deploying this technology that is not superhuman capabilities, but it is capabilities. They're deploying this at scale, again, to hundreds of millions of users. And I can guarantee that most of these do not understand the risk of this dynamic happening right now. So I would love to see a lot more of our discourse happening on these 100% certain risks that we are seeing right now. And we are moving faster than innovating in the aerospace sector, rather than having the public discourse be dominated by what will happen maybe in the future at some point. And so that needs to be clear for policymakers, that needs to be clear for research, that needs to be clear for any form of business that is building on top of this. And I think it needs to be clear to all of us. I think that's the most important thing for us to take away from this.
Right. So raise your hand if you're excited about AI tools that we can control and that really empower humans. Okay.
What kind of question is
Good.
that?
Now, excellent. Now, raise your hand if you're excited about AI tools that we cannot control and that basically just replace humans. Okay, one guy. So, how do we get the former rather than the latter? No offense to you. Since I have the last word here. Let me throw out a radical proposal and see if there's some consensus around it, okay? Suppose, so to me it's very, very striking when we talk about AGI and especially superintelligence, this is vastly smarter than us, that basically less than 1% of all the things that people here at Davos talk about, that they're excited about, you know, sustainable development goals, eliminating poverty, solving the climate, revolutionizing healthcare, transforming business, etc. Basically, almost none of that stuff actually requires superintelligence at all, right? And I think that's one of the reasons why when you say you have dinner with people, people mean very, very different things. Whereas I would argue that at least 99% of the angst that you hear from people like Jeffrey Hinton and Joshua Bengio and so on comes specifically from the fear of superintelligence that we could lose control over. That's also what freaked Alan Turing out when he warned about it in 1951. So for just a radical maybe consensus, suppose we all agreed that we're just not going to, as a species, we're just not going to build superintelligence before 2040. Most people will be fine with that because they don't even think we can anyway, so there's nothing to whine about, right? Moreover, we don't need it for any of the things that we're so on fire about right now, and that would give us, you know, another 16 years to figure out how we might be able to control such a thing.
It's interesting. I'm not sure. Do we have any time for? We started a little late. No, we're done. We're done. I feel like a soccer referee or something. Okay, this has been such a great conversation. Thank you all. Really interesting stuff, and thanks everyone for coming.